everyone, in this video we're going to be solving inequalities. So we'll be going through interval notation and what that looks like in detail. Properties of inequalities, we'll talk about that, and then we'll be solving some inequalities and combined inequalities. Okay, so let's first talk about intervals. And so you know intervals outside of the context of math. An interval is just like an amount of time or with a starting and stopping point. If you think of like a week, that's one interval of 7 days. And so with math, we have a starting number and a stopping number. And normally this is going to be for x, okay, for the inputs that we plug into, let's say, a function. And so we have what's called an open interval if we don't actually equal the endpoints. So notice that we don't have an equal bar here on our inequality. This says x is greater than a and x is less than b. So when you don't equal the endpoints, that's considered an open interval, and you use parentheses. A closed interval is when you can equal the endpoints. So notice this says x is greater than or equal to a, and x is less than or equal to b, and then that's when we use brackets. So when you can equal the endpoints, you use brackets. And sometimes we have a half open or half closed interval where we have an equal bar on one part of our inequality but not the other part. And so in that case, we have a bracket on one side and a parenthesis on the other one, like these two examples. Okay, so here's just a quick summary of what this is saying in math notation. So notice this is math language over here on the left, but if we translate it to sentences, that's what we have here on the right. And so in math, it looks like a bracket and then a, comma, infinity, parenthesis, but that means all real numbers such that x is greater than or equal to a. You start at a, and whatever number that is, you want everything larger than that all the way to infinity. And then there's an equal bar, so we put a bracket there because we can equal to a. And then very similar reasoning for the rest of these. Let's just do this middle one here. We have negative infinity to a with parentheses, means that we want all numbers less than a. So if we have our number a, we want all the numbers less than that all the way to negative infinity, and we don't want to include the a, so we put a parenthesis to denote that. We cannot equal that. And just a quick note, we cannot equal infinities. It's a concept, not really a number. So parentheses are always used with infinities because you cannot technically equal infinity because it's just a concept of something very large. Okay, so here's just a chart of the interval in words, what the inequality would look like, and then how that would look as a graph. So what I recommend is if you're trying to write something in interval notation, I always start with the graph, and then that helps me figure out how to write it in my interval notation. So for example, if I just pick this inequality right here, I would place a on my number line and then the number b as well, and then I would say, okay, x has to be greater than a, so I would start to shade everything greater than a, but it has to be less than or equal to b, so then I would go all the way to b and stop. And then there's no equal bar on the side with the a, it can't equal a, so I put a parenthesis, and then I say it's less than or equal to b, it can equal b, so I use a bracket. Okay, so that's what I normally do, and that helps me write my interval notation, which would look like this. So this is just an example of what you would use if you had numbers for a and b. Okay, so let's try this out. We're going to write each inequality using interval notation. Notice that we have equal bars on both of these inequalities, and we're going to use brackets for that. So this says x is greater than or equal to 4, and it's less than or equal to 7. And so in our interval notation, we just have a bracket with a 4 as our starting point, and then 7 with a bracket. And so again, if you want to, and I'll just do it for a few examples with you, if you put a number line, you have 4, you want x to be greater than or equal to 4, but less than or equal to 7, and you can equal both of those. So that's how I usually figure out that this is what I'm going to write. So let's try this one. Notice there's no equal bars this time, so we will be using parentheses, and x is greater than -3 but less than 0. So this is what it looks like in interval notation. So be careful. I do want to mention that this looks like an ordered pair. This looks like a point on a graph, but it's not. We are talking about an interval, so this is a starting point and a stopping point on a number line. This means I would start at -3 and I would take all the numbers until 0, and then I would stop there. So that's what that means. How about this one? X is greater than 3. So that's just 3 or more. So 3 to infinity with parentheses, because we don't have an equal bar on our inequality. And x is less than or equal to 5. That one, we want everything less than 5 to include 5. So we put a bracket on the 5. Okay, how about this example? We're going to do the opposite. We're going to write the interval for the interval notation of the inequality that we have. Okay, so notice this says from 0 to 3. So we say that x is greater than 0 but less than 3. But then notice this one is a bracket on 0, so that one's going to have an equal bar. 3 has a parenthesis, so we don't equal the 3, and so that is going to be our interval that represents. How about this one? This says from 3 to infinity. So x is just greater than 3. So what you can do is you can say 3 and then x is greater than that. But normally what we do is we write the x first. So this is the same thing. This is exactly the same as this statement here. This says 3 is less than x, but we would write it here as x is greater than 3. How about this one? 3 to 4. So we have x is greater than or equal to 3 because of the bracket, and less than or equal to 4 also because of the bracket. So x is between 3 and 4. And this one, it says negative infinity until 5. So anything less, or sorry, -5, anything less than -5 is what we want. So we want -5, but anything less than that is what we're looking for. So x is less than -5, but also can equal -5 because of the bracket. Alright, so now let's talk about some properties of inequalities. So we have a non-negative property, which says if I have a number and I square it, it's always going to be 0 or more, so greater than or equal to 0. And that's because if you take any negative number or positive number and you square it, it's always going to be positive. So 2 squared is positive 4, and -2 squared is also positive 4. Oops, 4, which is greater than 0. We have to include the equal bar though, because 0 squared is equal to 0. And the addition property of inequalities says that if I have a number a less than b, and then I add something to a and I add something to b, then notice this inequality holds. A was less than b, so when I add a number, a plus c is still less than b plus c. Very much similar the other direction. If a is greater than b, then when I add numbers, the left side is still greater than the right side. So just a quick example for you, if let's say I had 2 is less than 3, and let me add 1 to both sides. So if I said 2 plus 1 is less than 3 plus 1, this is true because this side is now 3, but now this side is 4. So that's what that property is saying. And so here's just a visual for you for how that property is true. Okay, so let's use the addition property for this example. If x is less than -4, then x plus 4 is less than -4 plus 4. So take a look. Originally, the x was less than just the -4. So let me highlight that here. That's this x is less than this -4. Okay? And then we add 4 to both sides. And then from there, you can simplify. So after that, after you added numbers to both sides, if you simplify, the right side is just 0. So x plus 4 is less than 0. Okay, how about this one? X is greater than 4. So if you add -4 to both sides, it's pretty much subtraction. But if you add -4 to both sides, you end up getting x minus 4 is greater than 0. Okay, how about multiplying? So express as an inequality the result of multiplying both sides of this inequality by 3. Okay, so what we're going to do is we're going to start with the original. 5 is less than 8, which is true. And then if we multiply both sides by 3, notice what we would get. We would just get 15 on the left and 24 on the right, which is still going to hold true for this inequality symbol. The left side is still smaller than the right side. Okay, how about this one? This time we're going to multiply both sides by a negative number and watch what happens. So 8 is greater than 3, which is true. But if we multiply both sides by negative 2, then look what happened. The left side became negative 16, the right side became negative 6, and look what we had to do. We had to flip the inequality symbol, because multiplying by a negative, the larger number, which was 8, now is smaller because it's like more negative. So this is now the smaller side of my inequality, so I had to flip the symbol. And this is always going to be true when we multiply or divide by a negative number. So that's one thing to remember with our inequalities. So notice that we had to reverse or flip the symbol because we multiplied by something negative. And so that is going to be here in our multiplication property. If I separate this one is, notice this is C is positive, C is positive. So these two cases, this case here and this case here, notice the inequality symbol did not flip. A was less than B, and so A times C is still less than B times C. Same thing over here. A is greater than B, and then A times C is still greater than B times C. But when C is negative, which is this case here as well as this one, then A less than B, when you multiply, you have to flip the symbol. So A greater than A times C is now greater than B times C, and the same thing on this one. And so the way that I like to remember it is if you multiply or divide by a negative number. Okay, so that's what the C less than 0 means. By a negative number, I just say flip. You could say reverse or take the reciprocal, but you want to flip the symbol, the inequality symbol. So this one is really the only thing you do different with inequalities than you do with equal signs. You have to remember to flip the symbol in this case. Okay, so how about this example? If 3x is less than 12, then look what happens when we solve, because you always want to solve for your variable. So we're solving for x, and so you can think of it as just dividing both sides by 3, but that's the same as multiplying by 1/3. And so if we started with 3x is less than 12, that's going to mean that x is less than 4 when we simplify and solve. How about this one? X is divided by negative 2, and that's greater than 6. So if we get x by itself by multiplying both sides of this inequality by negative 2, well, this is the property we just talked about. We'd have to flip our symbol because we multiplied by something negative. So flip this inequality. Notice it's flipped from the original. And so the left side is now just x, the right side is negative 12. So x is less than negative 12. And those numbers, if you plug them back into this, would be true. So just to show you what's going on here. Originally you had x divided by negative 2 is greater than 6. And this was the answer we got when we solved for x. So let's pick a number. So let's just choose something less than negative 12. I'm going to pick x equals negative 20. And if I plug it in to my inequality up here, okay, I'm going to divide by 2, and I'm questioning, is this still true? So I'm going to put negative 20 over negative 2, and that simplifies to 10, and 10 is greater than 6. Okay, so that worked out. So that's why we want to flip the symbol. It makes a difference in our final answer. Okay, how about this one? Negative 5x is less than negative 10, so you just divide both sides by negative 5, and you have to flip the symbol because you divided by something negative. So notice that we did flip this from the original, and so the answer would be x is greater than 2. So any number greater than 2, if you plug it back in right here into the original, it will satisfy this original inequality. Just an example, let's pick 3. Negative 5 times 3, is it less than negative 10? Negative 15, yes, is less than negative 10. So that worked out. How about this one? Negative x is greater than 7. There's an invisible negative 1 here. So you can either divide by a negative 1, or you can just multiply both sides by negative 1. And then remember to flip your symbol because you multiplied by something negative. And so the final answer here would be just x on the left and then less than negative 7 on the right. Okay, so here's some reciprocal properties for inequalities. They're pretty straightforward. If you have a number that's greater than 0 or less than 0 and you take the reciprocal, then the same thing is true. That number is still greater than 0 if it was originally, or if it's less than 0, then it still is like it was originally. And then if you have b is greater than a, but a is greater than 0, very similarly, if you take the reciprocal of all those, they're both greater than 0. And the same with a less than b, less than 0. Okay, so now we're going to look at some procedures that leave the inequality unchanged, and then next we'll look at some procedures that change the symbol. Okay, so pretty much you can simplify. Okay, simplify both sides of an inequality. You can add or subtract on both sides of the inequality, and you can multiply and divide by something positive, and your inequality symbols will not flip. They won't change direction if you do these things. Now the difference is when you are gonna change the symbol, and we would say like reverse it, then that would happen in two situations. If you interchange the two sides or replace something, then your symbol's going to flip. So that would just be if I said something like 3 less than x, but then I wanted to write that the opposite way, then my symbol would look like it flipped, but everything would flip. Everything would switch or interchange. So x greater than 3. And then the big one here is if you multiply or divide by something negative, then you're always going to flip your symbol. So we just talked about this, but if you divide or multiply by a negative number, then you have to flip your inequality symbol when you perform that operation. Okay, so let's just work on solving some inequalities. So solve this inequality, and you are trying to isolate x. So that is what we mean by solving. So get x on one side of the inequality symbol. So this one has a couple of things happening to x. The 5 is over on the left side with the x, so if we subtract 5 from both sides, then we get negative 4 is less than 4. But then we're going to divide by a negative, so that's where we're going to flip, because we divided by a negative 4, so we flip the symbol. And so we get x is greater than negative 1, which is the final answer. And if you wanted to, you can pick a number greater than negative 1, plug it back into the original, and you would see that it's going to be true. The left side will be less than 9. Okay, so pretty much you do everything you would like this was an equal sign, except for this note of dividing or multiplying by something negative. All right, how about this answer as an interval notation and as a set builder notation? So the solution set here says x, the set of all x's, such that x is greater than negative 1. But interval notation says from negative 1 to infinity. Same thing, just different ways to write it. And then this would be the graph. We would put our number at negative 1 as like a starting point. We want all the numbers greater than negative 1 all the way to infinity. And then we couldn't equal the negative 1. There was no equal bar, so we have a parenthesis. Okay, how about this example? So this one has x on both sides of the inequality. So we have to get those on the same side and then isolate x. Okay, so first let's go ahead and just move the 2 to the other side. So if we add 2 to both sides, then we get 2x is greater than or equal to x plus 5. Notice you just combine the 3 and the 2. And we want the x's on the same side, so subtract x from both sides. Okay, so x is greater than or equal to 5, and that's our final answer. So notice we never divided or multiplied by a negative number, so nowhere in our work did we have to flip this inequality symbol. It stayed the same direction the whole time. Okay, and so we just did our solving like we would with an equal sign on this one. No need to flip, no dividing or multiplying by something negative. So here's our solution set answer and our interval notation, and here's what this would look like on the graph. We want all the numbers starting at 5 all the way to infinity and including the 5, so we have a bracket. And here's another one. Okay, so this is called a combined or compound inequality, because notice what you have. You have two parts, and you can say it like this. You could say 4 is less than 2x plus 2, and you also could say 2x plus 2 is less than 10. But because that 2x plus 2 is common to both, and one is less, this 4 is less than that, and then this 10 is greater than that, you can kind of smash those together and combine them. Okay, so it's the same as two separate inequalities, just with and in the middle, because they both could be true. And so you solve each one. Okay, and so look what happens when we work on both. We have subtract 2 on this side. Same thing over here. We'll subtract 2 from there, and then on the left one we get 2 is less than 2x. On the right, 2x is less than 8, and then just divide both sides by 2, and we get 1 is less than x, and also 4 is, or x is less than 4. Okay, so then that would look like, if we put them together, x is greater than 1 but less than 4. And then on interval notation, it's just from 1 to 4. We want all of those x's. So we solved them separately, but we could actually have just solved them all together at once from the beginning. But this was just to show you that technically it was two inequalities, and we combined. They were combined in the beginning. We separated them to solve, and then we combined them back again at the end. We put these answers back together as a combined inequality and wrote that in interval notation and as a graph. Okay, so how about this one? So solve this inequality. Notice it's another combined inequality. So this time we're not going to separate them, even though we could say 1 is less than or equal to 2 minus x over 2, and 2 minus x over 2 is less than or equal to 4, but we could just solve this all at once. So on this one, we're going to multiply the left, the middle, and the right side all by the number 2, just to get rid of the fractions. Okay, and so that's what we end up getting. Notice the 2 in the middle divides with the 2 in the denominator. And so from here, next we want to go ahead and subtract 2 from the middle, the left, and the right, because remember your goal, you were trying to isolate x. And so on this one, this 2 minus x, we need to get rid of that 2. So we subtract it from the middle, but also from the left and the right side. And then we get 0 on the left, negative x in the middle, and 6 on the right. And one more step, we have to get just x, isolate just x. So divide the middle by -1 and the left and the right as well. But notice you are dividing by a negative, so you're going to flip the symbol. So you flip this one and you flip this one. You flip both because you divided by a negative on the whole thing. So both inequalities get flipped around, and we get 0 is greater than or equal to x, which is greater than or equal to -6. Now, we tend to not write it the way that we solved. We would say that this is more of our final answer, because we like to write things in order from small to large. So we would just flip everything over. We would reverse everything. So -6 is less than or equal to x, which is less than or equal to 0. And so as an interval, that would look like from -6 to 0 with brackets. And then this is what it would look like on the number line. Okay, so this is what I would do. If I was here, and let's say this was my answer, I would go to my number line next, and I would say, okay, I know 0's on this side, I know -6 is here, and x is less than or equal to 0, but it's greater than or equal to -6, and then that would help me write my final answer. I would say, okay, -6 is my starting point, 0 is my stopping point, and I want to use brackets because I can equal those endpoints. Alright, just a few more examples. So this one is a little interesting. We're going to solve this inequality. 2x minus 4 to the negative 1 power is greater than 0. But a negative exponent actually is letting us know that that quantity in the parentheses with the negative exponent on it needs to move. And so in this case, this is technically in a numerator. There's like an invisible fraction bar with a 1 there. And so that whole quantity needs to move to the denominator. And then what you do is you say, okay, now that negative 1, it becomes a positive 1. And that would be invisible because we don't tend to write the exponent of 1. So real quick reminder, if you haven't seen this before, if you have something to a negative exponent, let's say something like this, then what you do is you move the base, in this case you move it down and take off the negative. Or if you already are in a denominator, like let's say this was negative to start with down here, then you move the base up and again you take off the negative. Okay, so that's just a quick reminder from exponents. And so for us, that just allows us to rewrite our inequality and then we can solve for x. Okay, so using the reciprocal property, we know that if 1 over 2x minus 4 is positive, then 2x minus 4 itself is positive. And so then we can solve it that way and just add 4 to both sides, and then we'll just divide by 2 and x is greater than 2 is our answer. Okay, so we use our reciprocal property to go from this fraction to this one. And so we have the set of all x's such that x is greater than 2, and then 2 to infinity for our interval and as a graph. Okay, now this one we're going to be creating equivalent inequalities. So if we know that negative 4 is less than x and that x is less than 0, find a and b such that this is true, such that a is less than 1/2 of x and that is less than b. Okay, so we're given an if part that is true, and we're going to use that to find the missing values for a and b. Okay, so what we're going to do is we're going to make what we are given match what we're working with, which is in the middle, the 1/2 x. Okay, so we want to go from what we're given, which is x in the middle, to a 1/2 x in the middle. So all we have to do is divide the middle by 2, but whatever we do to the middle, we have to do to both the left and the right. And so we end up with a 1/2 x in the middle, and dividing the left side by 2 and the right side by 2, we get negative 2 on the left and 0 on the right. And so that lets us know pretty quickly just by looking that a is negative 2 and b is the 0. Alright, last one. So this one is about Ohm's law that says E equals IR. So E is voltage, I is current, and R is resistance. So an air conditioning unit is rated at a resistance of 10 ohms. If the voltage varies from 90 to 110 volts, inclusive means that you can equal the 90 and the 110, what corresponding range of current will the air conditioning draw? Okay, so inclusive between 90 and 110 looks like this. So notice that we have the equal bars, and that's strictly because of the word inclusive. That's how we know to put equal bars, and we want between 90 and 110. Now Ohm's law says that this voltage is equal to the current times resistance, so we could just replace. So we just replace the voltage by IR. And then we know, we were told that R was 10. So now just replace R with 10. And then notice you have one unknown at this point. You have just I. That's the only unknown. And we can solve for it. So if you focus on isolating the unknown, so for us, we're going to isolate the current I, then we need to just divide all three parts by 10. And we get 9 is less than or equal to I, which is less than or equal to 11. So the air conditioner will draw between 9 and 11 amps of current inclusive. So you can equal the 9 and you can equal the 11. Alright, so that's it for this one. Thanks for watching.